embedded part, and I'll be covering the security part as well. And we are going to see the various aspect of the wolfSSL. What's the advantage of wolfSSL? So let's get started. You guys can see my screen. Is my screen visible? Someone can unmute and tell me if they're able to see my presentation.
Yeah, it is visible, sir.
Okay, okay. We are going to speak about the wolfSSL and wolfMQTT. So the wolfSSL basically it's um, a security company completely based in United States, and they are known for their SSL and TLS libraries, which is meant for securing the communication which is basically used to secure the various communications like IoT or any communication which is using the cloud. Uh, so we are going to see what and why we are going to use wolfSSL, because there are many more libraries which is meant for embedded system or general purpose PCs. So wolfSSL is very much lightweight, and hence it's portable. And it's written in C. So it is lightweight, portable, so it can be easily fitted inside the any embedded devices. Mostly when we speak about IoTs, so people, I mean, they are looking for a good um, TLS libraries, and one of the well-proven library is OpenSSL, but since it's a very much heavyweight, which can't be fit into all sorts of embedded system. So when you are using a microcontroller, or when you're using ESP32, where you're using a Pico from Raspberry Pi, so they are having a very low footprint microcontrollers, and you can't fit Open SSL there. So you need to make use of some small footprint SSL. So the alternative is to make use of embed TLS or anything else. But seeing the security threat, this kind of TLS libraries don't have uh, like a very nice cryptographic mechanism. So wolfSSL is basically having good support because it is FIPS enabled. So we will be seeing about what the FIPS enabled FIPS concepts are. So it supports TLS 1.3. So when I compare this with one of the smallest TLS library, that is Embed TLS. So Embed TLS supports only TLS 1.2, not 1.3. So here, wolfSSL basically is superior than the other TLS libraries. it also supports it comes basically it supports it comes under two different type of licensing mechanism. So they do have a commercial license for it, and they do have one open source license which is under the GPL version 2. So we can for evaluation and hobby projects we can make use of wolfSSL. And when we are commercializing our product, then we have to use their commercial license. The advantage of using the commercial license is we can get a good support. Suppose we are using a different type of platforms, so there we can uh, I mean take their help to port on a different type of hardwares. So this is a small comparison between wolfSSL and OpenSSL. So the footprint is very small. It is approximately 100 KB, but sometimes it can be much more lesser than 100 KB if you don't need all the features. So yeah, I mean, we can customize this up to 20 KB. So this footprint is very much in line with the microcontroller's flash memory, whereas OpenSSL approximately takes 1 MB of uh, code data. So it's not easy to fit inside any microcontroller because the highest ever flash available for any microcontroller is 2 MB. Then embedded focus is not there for OpenSSL. It's very much the I mean the code is very complex, and the flow is very lengthy. It takes there's a big latencies there inside. It don't support any RTOS. It is definitely a FIPS compliant, but the other three features is not allowing us to make use inside the embedded targets. Even nowadays, where we have the embedded Linux environment, which is having which can support OpenSSL, but there also we started preferring to use wolfSSL because of its low footprint. Now let's talk about Wolf MQTT. So Wolf MQTT is something which is basically developed by wolfSSL community itself. This is so you might have heard about the MQTT protocol. This is meant for message queuing telematics transport, which is used for all the IoT devices today. So this is a custom version of MQTT, which is fully developed by wolfSSL, and this supports both MQTT version 3.11 and 5. So this is basically completely written in C. This is lightweight. The approximately footprint is 3.5, 3.6 kilobyte, and this is using Wolf SSL. So Wolf MQTT is powered by Wolf SSL. So in the background, it is all the cryptographic operations are doing by Wolf SSL. So um, since it's very much small, having very small footprint, so we can fit easily inside any STM microcontrollers. We can use even in application processors like Raspberry Pi. Uh, Again, uh, one more one more advantage of wolfSSL I just wanted to let you know. So it provides a wrapper of OpenSSL. So if we wanted to move out of OpenSSL to wolfSSL, so the portability is very easy because you don't need to replace any OpenSSL APIs. You need to just configure your wolfSSL to getting built along with OpenSSL's APIs. So it provides an APIs of OpenSSL, but inside those APIs will take you inside the wolfSSL calls. So these are just the wrappers. So wrappers are basically like pretending like we are OpenSSL, but internally every operation is taken care by wolfSSL. It provides both asynchronous and synchronous APIs like blocked and unblocked calls. So far, any question? Okay, let's proceed then. So let's understand FIPS. So FIPS stands for Federal Information Processing System. So this is a standard developed by the uh, by certain groups within the United States, and they wanted to basically secure their communication. So they defined certain standards because until this standards was not there, and when you are making use of any SSL or cryptographic libraries, so we are not sure that which kind of security has been taken care inside. There could be lots of security holes inside. So whenever we are making use of FIPS compliant cryptographic libraries, so we are sure that none of the non-FIPS options are there in that library, or it has been replaced completely. So some example, these are just very few and simple examples to understand. I have just explained here. Before that, I just mentioned about FIPS versions. So basically, there are two versions of FIPS available. It's 140-2 and 140-3. Sorry. So 140-2, it's already FIPS approved, and 140-3 is FIPS ready. It's mean it's everything is ready. It is under the approval stage. So for certain examples of cryptography is hashing. So we do hashing, we do encryptions, we do signatures. So for this hashing, we used to use certain options like MD5. So when you want to encrypt certain thing, certain encrypting and decrypting. So you can do it using the MD5 or SHA-1 or SHA-256 or SHA-334 or SHA-512. So SHA-512 is one of the most safest mechanism. So here, what happens, like MD5 is not secure. It has been broken already. So there are certain algorithms which can break it, which can recover the hash generated by MD5. So you can recover the data back actually without knowing the key. So uh, we made sure that when we have released when we are making use of the wolfSSL with FIPS features enabled, there is no MD5 at all inside that library. And if your application is trying to make use of any MD5 based hashing, so it will just give you an error because it will not be finding any support inside the library. So we are going to see this in the next slide, that how basically uh, this happens inside the embedded world. So any question from this or previous slides?
Is this FIPS 140 advanced or any standard inside this FIPS system?
Yes, I mean, so what happens, like um, they keep on identifying the different cryptographic mechanism which got obsoleted or which is easy to break. Can someone mute? Please mute your mic. And if you have a question, you can.
So, sir, I have one question.
Yes.
Like as you said, right, MD5 is compromised. So, like when we checked like SQL injection, right, in the cybersecurity in terms, like when we put the single quote and we win by bypass some username and password, at that time it will be like some cracking. They will without actual username and password, they can enter into that one. So what my question is, the developer, while developing the software or that some application or web server, right? The how they ensure, and every company they don't have that policy to black hat at red hat to verify that one. In terms of that one, how we can this FIP it will be useful. I mean, we need to be, while developing itself, we need to be make with using the tough algorithm, or how it will be.
No, I mean, no, from the user perspective, you are not supposed to do anything.
वो
When
जो
basically,
वो ड्राइव में डाले
when
तो कपड़े सूखने डालो। हाँ डालो,
uh,
चलो डालो, हो गया मेरा काम, सुबह का हो गया। वो है तो लूडो बहुत कपड़े वो हो जाते फिर जब
so sorry, there was someone I think accidentally unmute their mic. So from developer perspective, so you're not supposed to do anything. So just when we provide the platform, or when you choose the platform, so when you choose the platform, or or when you found as a developer that okay, your data might be getting compromised, so you can suggest to your stakeholders that I wanted to upgrade my uh, platform. So while basically doing the you are performing, like suppose you are you're saving your password. For example, if I take an example of my operating system, and I'm using Linux, and I'm having a password there. So earlier, uh, for one of my embedded target, I was using MD5 hashing for my passwords. So if someone gets the access to that shadow file, so that shadow file is a file where your password is stored in encrypted form. So by default, many operating system, or many older operating systems, they use MD5 hashing. So if I who is there basically taking care of all this cryptographic mechanism in the background? Your OpenSSL library. Until you tell your OpenSSL library that use FIPS only. So it's a bit a difficult job in a PC-based environment. You can still do. You can just download the source of OpenSSL, uh, configure it. So when you run the configuration, at the time you say enable FIPS, and then you can compile, build, and install the same in your PC. And then what's happened, like once the FIPS is enabled, it will never use MD5. There are certain instructions where you can tell that exclusively use SHA-512 for hashing. So basically, you can see all these things in your shadow file. So if you are using the Linux environment, you go and check your shadow file. So it will show you like what mechanism it has been used. Easily you can figure it out by seeing the uh, sh- uh, I mean the hash which has been stored. I mean how the password has been stored actually. So, did I answer your question, or I mean, you have something else to ask? Okay, so let's proceed. I'll go to the next slide. Okay, so before we go further, we will understand different keys and certificates which the multiple devices are using while we are communicating with external world. So basically, here I have mentioned only those keys, keeping IoT devices in mind. So we have a CA key. This is a private key of the certificate authority. So basically, there are many certificate authors like AWS, Microsoft. So they give you the I mean a public key, which is called CSCRT. Using that, we can basically sign our or we can generate our public keys. So we'll understand any. I will keep it very simple. All the files which you are seeing with key with the extension key KEY, these are all public keys. No matter it's a CA key or server key or client key, these are all public keys. But this is very much private, and no one will share this with you. So for testing purpose, you can create your own self-signed certificates. You can create your own private key, but don't share this key with anyone, because this is very much a specific, because if you share this key, so the people can easily generate the public key, and your whole communication system can be compromised. So either it's a Microsoft or it's Amazon, AWS. So basically, they are the certificate authors, and they give you the CA files. That's the public key. They give you the public key. That is CSRT. So after getting this one, what we do on our side, we generate first. The sequence is wrong actually. First, we generate the server key, and who is using the broker means the server basically. So these terminologies are used in IoT. So the broker is something which is deployed over the cloud and which is basically connecting with multiple clients, and it's basically forwarding client one's data to client two if it is subscribed. So it is basically helping you to publish and subscribe the data. So using this uh, CA certificate or CA public key, we generate the server certificate. And a similar thing we do for the client. So first we do is we generate a private key for the client, and then we generate a sign request. There is one more intermediate file which I have not mentioned there, because what happens from this key we generate a server. The sign request file, and that sign request file is getting signed by the certificate, this CA certificate. So once it is signed by CA certificate, it generates the client certificate. Similarly, the server key you generate, and then you generate a server sign request, and when it is signed by the CA key, then you generate server CRT. Now here, the main thing to understand is the two important things are the client CRT and the server CRT. And all these CRTs are basically public key. So now what happens when you are deploying IoT systems? So basically, you will be deploying first uh, one server where basically your broker will be running, and all of your clients whom you want to communicate with each others, irrespective of their locations. It can be anywhere in the world. So you will be specifying the server's IP or server's DNS. So in the secure environment, so you need to provide this CA, keep this secret. This won't be used anywhere else. This will be used only for the generation of CA cert, server and client cert. Okay. Remaining all things will be into the respective places. So these three files, the the CA cert and server cert and server key. So all these three files will be there with the broker. So because it's deployed in the server, so it will be with the server. Then CA cert, CA client cert and client key. All these three files will be there with all of your clients. So if you are having n number of clients, so you need to keep on generating the different files for different clients. But CA cert will be only the one for server and all the clients. So let's see that what are the basically the roles of these files. So when the communication is okay, let's see it in diagram. Let's see here. So basically, this is a TLS handshake. So when there is a non-secure communication, so there when you start when the server is running, when the broker is running, and when you start your client, it just sends a connection request, and the connection is getting established. So this is just a secure. I mean, it's a socket communication, and data is getting communicated over the non-secure line and non-secure internet, and I mean, uh, which can be seen by any third-party applications like Workshock. So here in the secure environment, after the connection established, we have to do the TLS handshake. So let's understand what is the different steps of TLS handshake. So client sends the connection request. Okay, so here there is something wrong here. So the right part is server. Sorry for the typo. This must be a server. So in the response, the server sends it's a response plus the server CRT. That's a server certificate. So then client sends its server certificate, and then they do a client key exchange method actually. So what exactly this process is a bit longer. So in this, what happens? The client first share the pre-secret key, and the server basically takes that pre-generated key. So okay, why this server.cert was sent? So I will explain you. When client sends its pre-secret key, that was encrypted using this server cert. Okay, so possibility is there that someone who was listening over the line can also get the server certificate because this was visible. Till this time, the data was not secure. So we will see in the coming steps that how we are going to make the data secure. So that's why we have different steps to make it sure that the communication is between two reliable entities. So there is no intruders in between. So when so take this example. So this server.cert was sent to client, and the client basically in the next step. Okay, so has uh, encrypted a pre-secret key, which is a very small key, and it shared that key with the server. Now the server can decrypt that particular data with server key. So let's go back once again. I'll tell you. So here we have the server certificates. This is also called as public key. That's why, because we give it to our clients. So what client will do? Client will encrypt all the data using this particular key. Okay, client is not encrypting the data using the client certificate. Client is encrypting the data using the server certificate. And once it is reaching to the server, then server will be decrypting using the server key. So don't share this one with him. Okay. So in case of any example, if some third party has got this server certificate, because at the first step, at the handshaking, the first step of the handshaking, the server has given server.crt to the client. So basically, client can encrypt and send the data to the server. So now the data has been reached to the server. The server has decrypted using the server key. Now it can read the data and vice versa, because client also has sent its certificate to the server. So what happens now when client sends any data which is basically encrypted by the server.cert. So server can open it using the server key. And when server will be sending any data using this client.crt, client will be open to decrypt using the client.key. So here in this pre-shared key, when the pre-shared key was shared with the server, then server has basically, I mean, it has decrypted using the server key. So basically, when client was sharing this pre-secret key, so pre-secret key is again a new key which client has generated, and it has encrypted using the server.set, and it has been sent to the server. Server decrypted it, and then they both have the same data now, and using that, they have generated a session key. So they both are having the session key for that particular communication only. So again, to say, just it won't be confusing now. I just corrected it. So next thing will be like, what is certificate verify? So as I told you at the beginning, there was a possibility that server.cert can be can was obtained by some third party. So during this server certificate verify, the server asked the client to share some data, any data, and which must be encrypted by client.key. And since the server now have the client.cert, so it can decrypt the key, the data which has been encrypted by client.key. So the client will do the same, and then it has been verified by the server that this is a genuine client. So now they wanted to tell, not change to the cipher spec, change the cipher spec. So till now, all the communication was happening with the given keys. Okay. Now, since one pre-secret key which client has shared with the server, that is obtained by server, and both are having both has generated the session key. So they are telling to each other, let's use this session key. This session key is very much specific for this particular session. So like we are in a session now. So for this particular session, a specific key has been generated. Like we all are in a call now. So our calls are basically generated using I mean, if it is a secure one, so it has been generated using using that particular session key. So if we break the communication and we establish a new communication, at that time a separate session key will be getting generated, and it won't allow the users from the previous session or on a parallel session to join the I mean the same another call. Basically, they need to drop and re-establish the communication. So Once it will be getting authenticated, and once again the session key will be established with that particular client, and then the communication will be established. So when they do the cyber, when they're changing the cipher spec, then they are agreeing that, okay, let's do all the further communication for this session using this particular session key, and using that particular session key, they are encrypting and decrypting the data. So they both are acting on a key, that is same key they both are having. So basically these certificates are used only till this time for these particular sessions. So when they drop the connection, when they reestablish, so all these steps will be followed again. So so far, any questions from this TLS handshake or from the previous topics? So, okay, I'll move forward. So let's understand the Yocto. So far what we have seen is basically the security feature. So since the beginning, we are talking about the embedded system, and we are going to see how this TLS library is getting implemented within the embedded system. So let's understand about the Yocto build system. So many of you, if you are from an embedded background, you might have heard about the Yocto, and many people calling it as Yocto Linux. So Yocto is not basically a Linux. Yocto is a tool which basically helps us to create a customized Linux. So this is an open source tool which helps us to build a custom Linux for embedded devices. It creates the tailored Linux images optimized for a specific hardware. For example, if your hardware don't support Wi-Fi module, if your hardware don't supports Ethernet module, if your hardware don't supports GSM module, so you can basically the standard Linux is having the support of all this. It's a very bulky uh, kernel which supports a lots of hardware. So here in this case, if you if based on your hardware requirement, based on your product's requirement, if you don't need a specific feature, if you don't have any specific hardware features, so the particular software components in terms of application, libraries, middlewares, or kernels, you can remove it. So this kind of freedom we get in the tool Yocto, and which helps us to basically create or tailor the image for our specific hardware. Apart from that, it produces a very small, efficient, and lightweight Linux systems. So we'll be seeing that in our upcoming slides, that how it can produce small and efficient, lightweight Linux systems. Um, okay, again, fourth point, it provides highly customizable and scalable environment suitable for complex embedded systems. So scalable environment and customizable environment, when I say, so the standard Linux, basically, if you see, it basically starts with a slash. It's a basic file system. So most of the time we don't touch that, but if required, we can alter or add our own folders there. Not just there, but anywhere else in the file system. So because home root or home users, these are basically the users folder where basically user specific data are getting stored. So when you are creating your own custom Linux, you can create, you have everything in your hand. If you want to customize this folder system, you can customize those folder systems. Uh, you can create your own or customized folders there. You can add your products folder there. You can add your uh, the drivers, which will be supporting an extra piece of hardware, which is basically meant for that particular project. So these are the features. There are many more to discuss on this one. So why Yocto? So because it provides me the customization, because there are other tools as well. if I'm going to work on the embedded Linux, so I do have build root OpenWRT, and there are a few more tools provided by third parties, but Yocto is the most popular one. So uh, it provides me, it gives me the option to tailor every part of the Linux. So I can customize my kernel here at just one place. So just one user interface. You don't have any graphical user interface. It's all command lines made in interface, and it's basically okay. If you wanted to make use of any graphical user interface, so you can use VS Code. So VS Code gives you an option where you can visualize everything inside the files, but not in forms of any tool. So you need to basically learn about the structure of Yocto, that how basically you need to add or remove the components from the layer and from the actual generated OS in form of layer. So kernel driver libraries and applications. So these are basically four different parts of any Linux or any operating system. So kernel is the core of operating system. Driver is basically a piece of software which is driving a specific hardware. For example, you have Wi-Fi. Um, so your Android phone is also basically running Linux inside. Android's core is basically the Linux. It's a Linux kernel. So if suppose you wanted to, okay, that's a great example. In the older version of Androids, so we don't have the support of Ethernet because there is no Ethernet port inside the mobile phones. But going forward in the new phones, we have the Ethernet support there. Uh, Many of you, if you are using a latest version of Android phone, and if you have USB to Ethernet connector, you can just plug in a USB-C on your Android phone and connect the Ethernet port on that. So you'll be getting data over the Ethernet. It will be much faster than your Wi-Fi. So, so these are all like highly customizable environment where if I don't need a specific hardware, I can remove those particular software. And the advantage of that will be the speed and the performance of my software will increase, the footprint will decrease, and many more. So it allows me to strip off all the unnecessary application library and kernel. For example, when I use my Android phone and it is a Snapdragon. So basically, I will keep all the support of a Snapdragon. I will remove all the remaining parts, which is meant for NXP or any specific hardware. Because when you download a standard Linux kernel, so it will be it's a generic kernel basically. It will be having the support for each and every um, hardware platform, which is officially added by the respective company. So basically, everything is maintained inside the main string kernel. So here, if I'm developing something for my particular product, so I will tailor off all these unnecessary kernel and libraries. So standard Linux comes with many libraries. So suppose I don't wanted to make use of, SSH. I want to make my SSH is basically a utility which allows a remote logging to embedded devices or any devices. It's not just limited with embedded devices. You can do the SSH login to a server as well. So you can secure shell basically. So I wanted to replace my because SSH functionality is provided by OpenSSH. So OpenSSH library is provided by is basically helping you to do the SSH inside any servers or any embedded devices. So if for my device, my specific device, I wanted to enhance the performance. So what I will do? I'll just remove the OpenSSH. But still I want SSH, so I will bring wolfSSH. So which is much more lighter and faster. So similar way, like if since this is basically meant for a target, so I don't want to make use of any tool chain, GCC and G++, and so I will remove all those development part again uh, from the Linux. Okay. Next is easy to integrate the third-party libraries just by adding the layer. So suppose I wanted to make use of uh, say wolfSSL, which we are going to see in the upcoming slides. So I will just download a layer. So wolfSSL team has created a layer for Yocto, and they, I mean, I will just pull that into my build environment. I will add that layer in my layer file, and I will just build, and that's it. Yeah, definitely. When I'm doing the customization, so we need to do a lot many things there. So integrating is easy, yes, but again, securing your OS takes several steps, which may take several weeks or months. For example, when I integrate my wolfSSL in my Yocto, then my next step, I'm integrating wolfSSL for a purpose, for a specific thing. What is that purpose? That purpose is basically to secure all of my communication. And what are those communication? My IoT communication, my SSH communication, my NTP communication. Okay, um, it can be, if it is an within the company, then open LDAP communication. Okay, and if you are using SNMP, then my SNMP communication or any number of communication. So by default, Linux provides all these services inside, but by default, they are making use of OpenSSL. So I have to go to the source of each and every library, and I have to change their configuration file, where basically we will be removing the support of OpenSSL, and we will be adding support of wolfSSL there. And at the end, we will remove the OpenSSL completely from the build system. So these are the different steps we need to carry out. Next thing is, Yocto provides me the overridable multi-layers. So it is having a multiple layers which is overridable. For example, as I told you, like Yocto provides me a layer for SSH, and by default it is using OpenSSH. So it gives me a flexibility of removing that OpenSSH, and I can add there wolfSSH. Similarly, Yocto provides me the flexibility of removing the layer of OpenSSL and add the layer for wolfSSL. It can be overridable, even or you can run in parallel as well. There is a possibility, definitely there is a possibility that you can run both OpenSSL and wolfSSL side by side. And many people do that as well. So next is basically, Yocto is divided into 3 layers. These are the very basic 3 layers. But when you search in the net, you will not be finding any diagram which will be explaining only just 3 layers. So these 3 layers are both support packages, which is meant specific for that particular target. Then the distribution layer. So distribution layer is very important. This basically you might have heard about different flavors of Linux, like Debian, like Red Hat. So these are the distribution layers. So similarly, Yocto provides, because as I told you at the beginning, so Yocto is a tool. It's not an it's not a flavor of Linux. It's a tool which helps you to create your own custom Linux. So suppose someone is interested to build a custom Ubuntu for their embedded target. So that can also be done using the Yocto. Yocto is not just limited with the Red Hat. Yocto can help you to create your customized Ubuntu for your specific target. Apart from that, it allows you to create multiple application layers or override or add extra layers in the application layers. So it comes by default with some default package, but when we take this and when we customize this for our specific targets, so we keep on um, customizing these layers. So next let's see the generic layers in the Yocto. So starting from the core, that is open embedded core, which is at the bottom. So this one basically contains the actual Linux core, where basically which is consist of the shell and the kernel. Then we add Yocto BSP layer, which is basically by default it is MetaPoki, which is a community edition. But when we write our own, when we do some production, so then we write our own, keeping MetaPoki as a reference. Then we have this all. So these are the two basic layer. In the yellow one, what we are showing. So whenever you download, you will be getting just these two layers, these two yellow layers. The all other layers, which is shown in the blue color, is basically external layers, which we keep on adding. So the very much important layer here is BSP layer, and without that, because we are just going to build a custom Linux for our specific target. So when you have your own specific hardware, you need to add a support for that specific hardware. That's called boot support package, which includes the kernel and the drivers. So many embedded system uses the UI layer. So basically, today nowadays everyone has started using of the graphical user interface. So it can be a Meta QT or Meta Genome. Anything you can make use of for your particular target. I don't deal with the any graphical user interface so far. So I don't have any experience of working on that. This is basically a um, the figure which I've copied from the internet. If you have some commercial uh, applications or libraries, so that is also getting provided here. For example, I told you about the wolfSSL. So wolfSSL is having a custom, a commercial licensed layer for Yocto. So when we pay them, so they give this layer to us, and then we can take and integrate easily with our build systems. Then the top one, the small one, is the user specific layer, where basically you can the end application one when you are developing. So you keep everything inside a layer, and you can specify there. You can basically do anything. It's not just like even suppose you're writing a C code. So C code you can write and fit. It's not just allowing you to write the C code, but it is allowing you to place the C code wherever you want in the operating systems. So that's the importance of this layer. So next, what happens? I will tell you about my uh, example project. So this is the layers what I have in my example project. So the top one is a meta zi. So you can give meta must be constant. It must be constant. You have to keep the meta hyphen, and then remaining part you can give any name to this one. So I'm developing a small project which is on a specific target, that's STMicroelectronics custom board, which is running a processor named ARM Cortex A35. So I've created one customized Linux for me, which is having these many layers. So these layers, I mean, the top one is the application. So which consists of this IoT applications, and then a few more, just the sample C code. Then I have an AI layer. So the idea is to build a basically a project which is going to do the predictive maintenance. So I have multiple motors just connected to different motor drivers, and my gateway, I mean this A35 board is basically going to get the continuous data from the different edge devices. So all these edge devices are connected to different motors, and I'm driving the motor. I am just reading how much current it is consuming, and I'm going to read the tachometer of the motors so that I can confirm whether it is running or not, or whether it got stuck. So based on various parameters, I'm going to train my model to understand what are the failure conditions or what are the upcoming failure cases. Based on that, before the fan or before the motor will fail, this AI will tell the user using the IoT that your machine needs and maintenance, or its health is degrading. Okay, so coming back to the topic here. Next is some extra libraries. So I have integrated wolfSSL and MetaGATC. MetaGATC is a general attribute profile. It is for BLE, Bluetooth Low Energy. So this two layer I added basically to MetaWolfSSL I added to make my line more secure. MetaGAT I have added to enable my edge gateway to communicate over to the edge node using the Bluetooth Low Energy. Then this BSP layer. So in this is provided by the company itself, the MetaST, because they have developed the BSP layer, the MetaST layer, specifically for this board. But I have created Meta custom kernel because I wanted to customize my kernel. The reason is I wanted to make my kernel as a real time. And these two layers pulled directly from the Yocto project, from the GitHub. In fact, everything is pulled from the different locations of the GitHub. So build flow of the Yocto. So whatever the layers you have seen, those are basically the sources. If you go to the previous slide, so here definitely everything I have mentioned in different layers, but how they are getting built. So these are the sources. So as again I told you, whenever I pull these different layers, so many of these layers are present only in my system. Many of these layers are pulled from Git. The good practice is, even if you are generating your own custom application or your custom libraries, put that also into the GitHub. And I did the same. Even in my custom build, I mean, my custom application, which is inside the Meta ZI, is also in the GitHub. So you pull all the sources from either from GitHub, HTTP, or SVN, or something, or anywhere else. Then in the in your build systems, you're having the bitbake files. Bitbakes are basically it's a system which basically pulls configure and then compiles. So its compilation is not direct. It looks for the dependencies as well. So it is having any dependencies on any particular libraries, then it will either download, or it will, if it is downloaded, then it will configure and build those libraries first, and then it will build your application or your libraries. So once build system will pull and build everything, then it will generate the 4 different components, which are the binary components. These are root file systems, kernel and device trees, bootloaders, and SDK. So SDK, we will be telling you like what's the advantage of SDK, because once your operating system is ready, you deployed that operating system inside your target, and it's not that feasible that every time when you are testing your application, every time you go and build the whole operating system and flash it. It's a lengthy time. It takes hours. So the good thing is basically the Yocto allows us to create the SDK. So when we generate the SDK, this creates one built environment for that particular hardware. So this SDK contains all the libraries, which is the part of uh, that operating system, so that you can basically develop any application or keeping or linking with those libraries, and then you can deploy immediately these applications on the target. Okay, so this basically helps you to basically develop and debug and fix your application faster. So these are the different components. So basically using these tools, these are the different layers and tools that we have discussed in our previous slides. We have created one example projects. So these are the different components of our example projects. So there is one thing which is by mistake printed, that is Raspberry Pi. So here we have MP2 instead of Raspberry Pi. But yes, we do have our cloud, our broker is deployed in Droplet, which is Droplet is basically operating system running in the cloud. It is as good as like you are running a Linux machine in your PC. So the Droplet is basically an operating system running and deployed in a cloud, and it is having a public IP. So across the world, everyone can see that public IP, and that is what we are doing here. So we are making use of MQTT. We are making use of TLS 1.3. It is secure OpenSSL, secure OpenSSL. Also, we are using. It's a FIPS ready because I'm making use of FIPS 140-3. We are making use of DigitalOcean. So these are basically the different components of our example project. So here is a simple example project where basically my device. So this is basically the secure gateway, which is an MP2 board running ARM Cortex A53. Sorry, ARM Cortex A35, which is a dual core, 1.5 gigahertz each core. The system is having a 4 GB of RAM, and it's running our custom Linux inside it. So basically, this is having a connector inside. The connector's name is fan controller. So when we invoke that for fan controller, this comes in a single application. So basically, this first it is trying to communicate with the DigitalOcean. So one thing, if you are having the proper certificates generated here in DigitalOcean, then only it will allow the gateway or any client to get connected to the cloud, unless it will reject, because it's all secure communication, and we have disabled all the other ports. So the user basically is observing, and user know through its app that what data it has to send to the gateway, the edge gateway, via this cloud to basically control the fan speed or or turn on or turn off the fan. So the users, either they are making use of the mobile phone app or a PC app, they also need to obtain the certificate from the cloud, unless they will not be able to communicate. They can generate their the certificates there, but they need to have at least the CS cert from the cloud. Okay, so before we see our demo example, yeah, so far anyone is having any question, including anything from Yocto in embedded Linux or anything from embedded system as well? No questions? Okay, so I'll proceed. So I'll just open my is my VS Code visible? Okay, so this is my built environment. So so far I was speaking about various things. So I'll just go to my actual directory. So here, this is my actual Yocto folder. So I maintain all of my applications inside this git underscore file because it's easy for me to check in and maintain my custom development here. But let's go and see inside the distribution package. So here, this is the actual Yocto folder where basically I have layers. So I can show you either from the command line or here on the left menu. So this is consist of, I think this is bigger one to see. So here, let's go inside the layers and see what are the components we have. As I was showing you in my slides, I have this meta, okay, starting from the application. So there I have a meta ZI. So if you see the structure of meta ZI, this is consist of multiple recipes inside. So if you see, this is a bitbag file, which is basically helping you to create and create or basically compile or whatever you want to do. So bitbag files basically helps you to do whatever you want. For example, within this build. Okay. So for example, here if you go, let's go to the MetaZDI directly and then RESPZDI and then my app, go to the files. So you see there is a C file. There is a C file. So I'm just going to control some piece of drivers through this one. So it's a simple plain C code. You can write for if you want to learn basically you can just start a simple plain C code like hello world or something. And it's having a make file as well. And then go to the bitbag file. This is very important. So here we need to understand here. So here we are maintaining MD5 only for hashing. It's not for communication at all. It is just to make sure that file is correct or not. We are just making use of MD5. That's all. So here I'm just mentioning my different files which I have in that particular folder. Then what I'm doing, see, first I said do compile. So basically this bitbag file is the actual uh, uh, active agents within the Yocto, which helps you to tailor or customize your build. So here I'm compiling. So I've mentioned CXX basically when you say these are different terminologist. Here, it will, if you have to specify like this. So this is making use of C++ compiler. If you want to make of C compiler, then use CC. So it is making use of this compiler. It is compiling and generating the binary. So when you use inside this bitbake, during this build, it will make use of the same compiler which it is using to build the other components. Because when you build Yocto, it will basically uh, download and build. So build means it will compile everything it will do. Then once it's built, then it will do install. So what happens? See here, we are telling install this directory. So inside /home/root. Then next step is /home/root, because by default /home will be there in the Linux environment. So /home/root/application. So then you are basically moving this app and this GPI. There are two applications you generated here. See, this is the application one, my app, and GPI is the second application. So two applications which I am generating. I'm asking them to go and install here in these two folders. So it will basically go and install there. So these are basically certain things. So this recipe is completely written by the user. That's me here in this case. Next is if you see Meta wolfSSL. So here I have done nothing, but only the thing is I need to check my I just used git and I cloned it. So we are just git clone and the link provided by the wolfSSL. So I just pulled that here and I just added this where I have to add this in my YAML file here. I have just to specify. So you can see these are my custom layers. Meta ZI, Meta wolfSSL, Meta STX Linux AI, and Meta GAT. So Meta GAT client actually. So I have added these layers. So you have to specify these layers so that those layers will be getting built along with your build. Now next part. So I just downloaded and specified build this one. But the thing is, you need to see the branch. If suppose you are building an Yocto for the older versions. So we are in the master, you see git branch -a. So you can see for older versions also, the support is available. That's Kickstone. So these are a different branch. So suppose your Yocto is basically meant for a specific version. So those features you can see here and you can build accordingly. Okay. One more important thing about Meta Cat. This layer doesn't exist actually. So this layer I created because if you go and see here, Cat here in the not in the font, sorry, in the big file. That's the display. So here we are basically making use of a third-party library. So this library was there, but this was not a part of Yocto. So it's very easy because since I'm talking about Yocto, so I'm just telling that even if the third-party bitbake file or the layer is not available, you can create your layer. So you can create a layer like this. So these are basically a syntax of writing the layer. So you write, so it will pull when system is getting built. So it has seen, okay, when it comes here, it sees, okay, I need to pull the source from here. So it will pull the source from here. And here I have not wrote anything for do compile or do install because I have given everything in the hand of CMake. So CMake, so that's another kind of flexibility, which basically systems or the Yocto provides me. And that's why it's making Yocto very much popular. So you just call CMake, and since this is a CMake project, it will build and install this library. Okay, and at the end, we will be having a complete image, a flashable image, which you can put inside the SD card and you can put inside your embedded target. And when you switch on the device, it will boot up. So before we see the demo, so anyone wants to discuss anything on any of this or something which I couldn't explain or I missed out or anything else? Any questions? Am I audible? Can you guys listen me? Okay. Okay. Oh, no, I think not from my side. Okay. Okay.
For unmuting.
Yeah. Right.
As a layman, if you speak out, what are the things we require to do this project?
Uh, uh, can you sorry, your mic is muted again.
Yeah. Like what
So
like to do this project, right? IoT project. What are the physical things? As you said, Raspberry is not used. So if Raspberry is not used, what are the other substitute and what I can use to do this one?
okay. So I'll tell you. You can make use of Raspberry Pi as well because if you wanted to make if you wanted to learn Yocto and AI in depth, you can definitely make use of uh, your Raspberry Pi as well. But Raspberry Pi is a bit costly. So I can basically tell you about this board. I'll link about this board, which you can buy. Okay. Uh, the, the, the components may be vary. For example, I was telling you about this particular layer. So if you see, this is my AI layer, which is meant for specifically to my board. But when you going to make use of Raspberry Pi, definitely you can you can make use of TensorFlow Lite or TensorFlow. If you wanted to make use of if you wanted to make use of TensorFlow, full-fledged TensorFlow, then for Raspberry Pi 5, you have an add-on TensorFlow a board available, which is connected via a PCI slot. So what you can do is, I mean, you have both options. So the reason is like I will suggest if someone wants to get into the industrial domain, okay, then they can basically make use of this board because this is a cheaper board. You will get it for $75 and 75 to 100. I'm not sure. I'm not very much sure. It is in between these two. When I bought 2 months ago, so it was 75. Though I have a free version. So another thing is like, I mean, here, if you go with this one, you are having various example projects available. So what are those example projects? Like face detection, So a lot of add-ons are there for this particular board. You can integrate one camera, and they have, because the team within this company developed many example projects where I'm just telling about if you are interested in learning the AI or IoT. So, I mean, those example projects basically consist of the motion detection. I mean, but this motion detection is basically very much customized for the particular use case. For example, a guy who is walking from in front of the door, who is having a uh, motion detection sensor, and if the guy passes, it will open. Though if the guy is not going in the direction of the door, he's not going from that door, but it still it opens. This is one of the bug in most of the motion sensors controlled doors. But here they have developed very much specific that if your intention is to go through that door, then only that door will open, unless that door will not open. Next is like it's used in various gaming desktops. So whenever you are not in front of your monitor, it will switch off your monitor. It is used very well inside the industries for the use case, as I told you, the predictive maintenance. So that basically I'm doing now. Uh, so basically, I will be integrating all type of different type of motors, and I will create a model. I'll keep on training that model for several conditions. And once it is ready, once it will be tested, then we will deploy as a prototype somewhere to basically understand how well it's working. You can do this as an attendance systems in your office. So so basically it can open the door if the employee has arrived, you need to swap the card, and tailgating is also not possible, like a number of applications you can think of. If anyone wants to ask any more questions, so they can unmute and just.
Sir, could you please share that link, the device, so we can use and we can go through that?
Sure.
Thank you.
So I'll just post it here. So you can learn more about this device. And you can see, like in India as well, like a lot of vendors are there through whom you can buy. And I think there is an offer going on from the company where if you buy, yeah, the shipping is free. So next, basically, I will just show you some sort of demo here. So this is a PC-based app, which is meant for MQTT. So here, basically, I'm just going to connect to my cloud, and the cloud which I'm going to make use of is DigitalOcean, and let me quickly turn on my board as well. So using the SSH, I logged into my system. Okay, another thing. So today, if suppose someone wants to learn the some sort of development in the PCs. So recently, because I'm just adding this point because recently I moved from VMware to WSL. So for all of my development within my PC, I use WSL, and whatever the code I was showing you in the VS Code here. So this is a environment within the WSL. This is a Linux environment which runs as an application inside the window. So it gives you a lot of flexibility to basically build. I mean, you get complete feel of Linux inside your Windows without basically switching your operating system, or without overburdening your PC or laptops, because you're not using a VMware. So there are certain pros also from the VMware, because it acts as a separate PC for you. But the cons are more, because it's taking a lot of resources from your system. It's making your PC slower. So if you wanted to learn it, all this kind of development, because I moved each and every development inside the WSL. I used to use VMware earlier. Okay, so now I'll show you, like, when I have just completed the build, I've deployed into my target, and I will log in into my target using a secure shell. So this is my machine. So if you see the IP address, sorry. So this is my target. So these are having different network interfaces. So I was showing you the my user quick. I mean the meta layer of user, which was metazeti. So I have shown you that how I created a folder here and what are the contents inside the folders. So if you see, it is home, root, and application. If you see here in so home, root, application. So this was created as a part of this bitbake. So the contents of that is like my app, and this both came from the build system. But later, as a part of development, MQTT and SPL, this I am developing. So I'm making use of the SDK. So once my build system was ready, I created and populated my SDK. So where this SDK goes? So I just show you this SDK is installed. This is my WSL, and inside this, if you go to OPT, it is inside ST. If I go to OPT, so if you see inside, this is a sysroot. Yeah, WSL is actually a Windows subsystem for Linux. So here, there are two folders, and if you see the content of Cortex, so here it is the actual file system which is there in my actual hardware. So, but this is in my PC. So when I build, I'll be showing you my applications. So I'll just go back to my VS Code here. So these are the certain things which I have used for building my OS. But now, for testing purpose, I'm building everything inside my application. And here it is all inside wolfMQTT fan controller. So this is a particular application which I'm just developing. So if you see my source, first I will take you to my make file. So you see, I'm just pointing to there, because this application I'm building in my PC, but this application is actually meant for a specific hardware. So so that's why I'm pointing my sysroot to the libraries which I've just built it for the particular hardware, because it's pointing everything. All the this application will pick not from my local system. This is also a Linux environment, but I don't want my application to pick any of the libraries from my local system, but to pick everything from the folder from where all the binaries has been deployed uh, for the custom hardware, for which the operating system has been developed, and for which I'm developing the application. So this is my make file. Next is this code. So here, any questions? Sure. So next thing is, if you go through my code, which is here. So basically here we are creating the different threads. It's all Linux concept. And then we are creating the connectors, which is basically hooking up with the broker. And then we are establishing the connection. So one side, we are first trying to create a task which is discover the devices and which goes on searching what are the local devices I have. And based on that, it informs the um, devices in, to the broker and all the connected users. So let's see the demo. So all this developed code has already been deployed in the target. So I just open my target here, and here I go to MQTT folder. Here, the fan controller is basically my current application, which we are going to see as a demo. So this fan controller is reading all the cert files from here. So let's run the fan controller and see what's happening. Okay. Okay. So I'll share you one more. This is very interesting part. This is something which is written in MicroPython, and this code is running on my microcontroller. So even for quick prototyping, this is one of the greatest thing to explore on. This code resides in my PC only. It's not there in the microcontroller. I have not yet flashed because I'm just doing the POCs. So this is the edge node. So first I run this. So when I ran this, it started advertising. So advertising is the concept of the Bluetooth low energy. So it started telling me that Bluetooth low energy is available. So if you see in my, I go to my BLE folder first, and then I run for the scan. So you see, we found one device, the 4.fan. This is the fan which basically I'm making use of. So I find it's okay. Now it's available. So I go back to my MQTT app, MQTT folder. Okay, there I will run the fan controller. So here it is trying to establish many communications. So you can see it is found the fan here. It's found this device. Basically, this is my target. I wanted to control that. So now what's happening? It is basically publishing and publish and subscribe. There are two different threads it's running inside. So, okay, let's go to a PC-based app. You can also download and can make use of this one. But only the thing is, I can tell you my IP address. You can basically try to connect that one. But the thing is, since until I will not share the certificates with you, you'll not be able to connect with it. You can try it. I can tell you the IP address. So I mean, see, you can see it's this application is also connected with the same app, and here the IP address is this one 139.59.24.104, and the port number is 8883. So any of you are basically, if you're having app, or you can use the web app as well. So you can specify this IP address and try to connect, but it won't allow you to connect there because it needs certificates. So you can see here the mark is SSL. So it's a completely secure line. So we are the communication what we are doing is over secure line. So no one can even see or no one can even connect there except the authorized users. And authorized user is those whom basically I authorize. Okay. So I will just on the camera. So you can see my fan, which is in the stop mode. It's not running at all. And you can see the status here in this. It's a final state showing as 0. I mean, that's the off state. So here we supports only 5 state. So because these are POC, so nothing more is specified, but just in a demo, I can tell you. So there are 1 to 5 speed and 0 is a stop. So when I say 1, so you can see the fan started running. Okay, and the flow is, I'm sitting like thousands of miles away from you. My server is deployed in Bangalore. This DigitalOcean is actually in Bangalore, this server. So when I hit this button over the secure line, the data all the way from here, the data went Bangalore. It hit and from there the broker redirected it to once again to my another device, and it came back here and it turned on the fan. So next is the speed, the different speed, and you're seeing fan speed is saying it's okay. Okay. Next is I will just go to the highest speed. So I got I mean my fan speed has got increased now. I think it might be visible in the camera, and then I will turn it off again by saying at 0. So you can see the fan's condition in the camera. It will go off now. Shut it down now. Okay. So I mean, so it stopped. Yeah, there is a delay because we have some wait time here actually, because in the background it's communicating with Bluetooth and it's keep on scanning the status as well from there. So I mean, yeah. So there's a small delay. Okay. So any more question from anyone? This you can unmute and talk now. Fine. If you don't have any, I mean, more questions, so we can just stop here. You can share your feedback. So thanks everyone for attending. I'm just closing the session now. Abrar, do you want to tell anything?
Jazakumullah khair, Zafar bhai, for your excellent session and sharing your experiences. And thanks everyone for joining. And you can connect with Zafar bhai on the LinkedIn, and inshallah you can have further discussions. So shall we close, Zafar bhai?
Sure. I will just post my, as someone asked my WhatsApp, so I'll just post my number.
Okay. Yeah, but please take care. Don't disturb him too much. He's an extremely busy person. So only if you have some necessary things to ask, only then
Sure.
you connect with me.
Sure. Okay. Thanks a lot. I'll just drop off now.